All right, this is trigonometry, and we're going to go through and we're going to verify both sides of the trigonomic identities. Both sides. Okay, if they both look complicated, do both. See where they go. So work both sides a little bit until you actually get a nice something easier that you can make it into. All right, this one right here. So let's take a look. So I'm going to rewrite this. So we're just going to work the left side. It all looks complicated anyway. So secant is going to be 1 over x plus tangent, which is y over x, all over 1 over x minus tangent, which is y over x. Yes? Okay, good. So I'm going to work the left side. Actually, let me rewrite this one too. So it's 1 plus 2y plus y squared over x squared. All right, so which one actually looks more complicated? The left side. Let's do the left side. Now, having fractions over fractions, you could clear it all up by multiplying by the common denominator of everything. What is the common denominator of the top and the bottom? X. So I'm going to do that. I'm going to multiply top and bottom by x over x. So as I distribute this, what's going to happen to my x's? X's cancel out. So I'm now left with 1 plus y over 1 minus y. Wow, that cleaned up really good, really quick. Right? Now, I have squares over there on the right-hand side, don't I? So what I'm going to do is, I'm going to multiply by the conjugate. Remember that? We talked about that the other day. Yes? No? Yes. We did. Conjugate. What was the conjugate? Same thing. Different signs. Same thing, different signs. But I'm going to do it at the bottom. Okay? I'm going to go for it on the bottom because if you notice on top, I got a bunch of pluses, right?
Yeah.
And on the bottom, I got a minus.
Yeah.
So I'm going to take care of that. I'm going to just do the bottom part here. So I'm going to multiply by 1 plus y over 1 plus y. Now, when I'm multiplying a binomial times a binomial, what's that called that I have to do?
Factor.
Not factor. Factor divides it out. This is something a lot of people did in here. Fail. So, first across, inner, last. First across, inner, last. Okay, let's go through this. So, first, across, inner, and last. So, let's start with the top, the numerator of all this. So 1 times 1. 1. All right. So it's 1, right? Now, all the way across. So 1 times y is?
Y.
Plus y. Now, inner. The inner 2. So it's going to be y times 1.
Y.
So plus y. And then last. Y times y. And now in the denominator. Okay, so watch. Let's do it again. Let's fail again. 1 times 1.
1.
So now, all the way across. 1 times positive y. Plus y, right? Now, inner. Negative y times 1.
Negative y.
Negative y. And negative y times positive y.
Negative y squared.
All right, let's go through and combine like terms now. On the top, I'm going to get 1 plus 2y all over 1
Minus y.
1 minus y squared.
And that's x squared if I'm correct, right?
Yep, and this, because the identity that we've been dealing with, the Pythagorean identity, I'll show you the... Yeah, I'll show you the Pythagorean identity. I'll do it again. So it's going to be x squared plus y squared equals 1. And if I subtract y squared from both sides, I get x squared is equal to 1 minus y squared.
Yes.
Okay? So I could use that Pythagorean identity now, right? So on the top, did I get there already for the top? Yeah, I got the top. So it's 1 plus 2y plus y squared all over x squared. Now, was I able to verify this was still only working one side?
Yes.
I only had to work one side. And the reason why this works out so well is because the way I have taught you guys to do this, to change it to x's and y's, your math cleans up really quick. It's easy to see. The math, all of it cleans up. Now, since I verified it, I could leave my answers to this. Because my left side is now equal to the right side. Okay? Are we good? Okay. Example 5 again.
Ooh. Are we doing example 5?
We just did example 5.
Oh.
But they did it a different way. So I still have it in the notes. So yeah, so they did the conjugate like we did already. This one right here, is this the one I was thinking of? Blah, 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 blah.
Way different than yours.
I know, right?
How did they get what? They backed
Yeah, it's completely different. So if you're just trying to look at the notes are completely different than what I teach to what they actually have in the notes. Mine is quite specific to this class. No one else actually does it like this. So this is a lot easier. Everyone's told me this is a lot easier than the way they actually do it with just straight identities.
Yeah, I also watch I too.
We don't gotta do this, do we?
No. And example 6, it's basically just asking you to plug stuff into the formula. It's just asking you plug these things into the formula. Capacity, inductor, blah, blah, blah. They're there. Okay, yeah. So yeah, on this one right here, I remember I put it here, but I still wasn't going to do it. Just to show you, all you do is you plug in the variables that they give you. They give you all the variables that you plug in. You plug it into your calculator. That's it. All right? Don't forget, like, subscribe.
And punch that bell so you know when he uploads.
Yes.